Hey there guys, this is Luke Seibold from PhyziX, and today we're going to be looking at the SI system of fundamental units. Okay, now you may have heard the International System of Fundamental Units described as the SI system. Now this is because it comes from the French translation for it, which is Système International. So the letters are kind of switched. So let's take a look at what some of these units are. So first of all, we'll write down, this will be the quantities, and over here we'll say what their SI units are. So the first quantity we're looking at is mass, and this is represented by an M. And the SI unit for mass is kilograms, which is a kg in SI units. Next we're going to be looking at length, and that is represented by an L, and the SI unit for length is meters. Then we have time, which is T often, and this is measured in seconds. So right now we're looking at a bunch of units that you see kind of in day-to-day life. So they're pretty easy to remember, but now we're going to be looking at some units that you may not have seen. So the first one we're going to look at is electrical current, which can be actually represented by an uppercase I, and that the SI unit for current is amperes, which is an uppercase A. Next we have amount, which again, another kind of strange unit. It doesn't really have a letter to represent it, but another kind of strange unit, which is the mole, and this is represented by an MOL. Now, what these mean right now aren't super important. We'll come to them later when we discuss the different concepts that are associated with these units. But for now, just keep these in the back of your mind because they will come super handy later. So next we have temperature, which is represented by an uppercase T. And though you may know of temperature as being measured in either Celsius or Fahrenheit, according to the SI units, it's actually measured in Kelvin. Now, Kelvin is pretty similar to Celsius. The difference between each unit Kelvin is the same as the difference between each unit Celsius. However, they differ by 273 units. So when Celsius is at negative 273, Kelvin is at 0. And at this point, all the movement of all particles in an object are completely still. Now, we've never actually been able to achieve this, but it's more of a theoretical concept. We'll probably be talking. We will be talking more about that as we come into thermal physics. And so the last one is one that you really don't see very much, but is still an SI unit, is intensity of light, which is actually also represented by I. So don't confuse this with current. They shouldn't ever really come up in the same equations, but just be aware that it is represented by the same letter. And this is measured in candela, which is CD. Now, I know that this probably isn't the most thrilling of physics concepts, but I really do find that knowing your SI units can help so much, especially when you're dealing with larger numbers and more variables. By understanding how these SI units can be manipulated and combined to derive other units that will give you the result you're looking for, can be so helpful. So although it may seem boring right now, if you just keep these in the back of your mind, and if you're constantly using them within equations as you're learning them, you'll be able to see how by taking values with these SI units, you'll be able to see how they either multiply with one another or divide in order to give you the derived unit that you're looking for, and therefore the result that you're looking for.